Okay, so we're going to look at a quick GeoGebra tutorial for those of you who want to use this to verify your results for your summative. First of all, first thing you're going to want to do is choose the layout window so that it closely resembles your sheet, depending on the orientation you've chosen. If you've chosen landscape, something like this, you can adjust the way the sheet looks by changing the size of this window, or you can just change the size of your overall window. So if you're landscape, you're going to look at something like that. If it's portrait, you're going to want something that looks about the size of a page held upright. So that's about the proportions of an 8.5 by 11 page. So I'm just going to use more of a landscape here. So the first thing you're going to want to do is choose the size, choose the scale. So you've selected your scale. And the easiest way to do this is to right click on empty space. Actually, let me just change the size of the font here to make it a little bit more accessible, a little bit more easily seen on your display. And so I choose some empty space. So here I'm in the middle of a grid and I go to graphics. And the first thing I'm going to do is under the basic tab, there's the basic tab under dimensions, I can put in my lowest and highest value for the x-axis. So you would look on the graph that you've already done and you might have a lowest value of, well, let's imagine we're doing one where the x and y axes are in the bottom left hand corner, the origins in the bottom left. So you might have something from -5 to positive, let's say positive 35. And you might have something that goes from -5 in the y to positive 20 in the y, something along those lines. And you can see as I'm doing these things, stuff is adjusting automatically in the background. Now, technically, you can probably get away just with this. But if you're a real stickler for detail, you might actually want, for example, if your scale is you have 1 for every grid line, which is probably the most common scale, you're going to want to go back into the graphics view and you're going to look at grid, and now you're going to choose. This gets done for you automatically. It's quite grayed out. I don't even know if you can see it in the video, but right now automatically it has chosen distances of 2 and 2. And if you look at my scale on the graph, every 2 units is 1 grid line. I can override that and I can change those distances to 1 and 1. And if I do that, you can see now I've got a grid 1 and 1. So let's just go ahead and assume that that's correct for you. If it isn't, you can do some trial and error and try to come up with something that works. So first of all, let me go over how I demonstrated this in class. Let's say that we are trying to verify our quadratic function. So in the case of quadratic, then f of x is going to be equal to x to the power of 2. And there is my quadratic. So that's going to be my parent function. So I'm just doing this for the sake of this video. You certainly don't have to do this. I am just going to change that into a dotted line to make it clear. That's our parent. That's actually not part of our graph. Now we want to transform that parent function according to the transformation y equals a f of k bracket x minus p plus q. So that's the transformation we want. I'm just going to change the size of that a little bit. Okay, so there's the transformation we want. So how do we apply that? So let's imagine that I've graphed mine already and the origin of mine is or the vertex, let's say it's somewhere over here. So it's at 10, 12, which means it's going to have been shifted to the right by 10 and up by 12. So I could put in my equation, my transformed equation would be y equals, and I'm going to mix it up a bit here, a little bit different than what we did in class. I'm going to say negative 0.5 times f of bracket x. Now I've run into a problem with this before. So we'll see if it works this way. So it's 0.5 times f of bracket x minus 10, close bracket, and then plus 12. And when I did this before, oh yeah, so it's working this time. So long as you're careful entering it, then that's fine. Just be careful though, if you end up getting a weird function, go back up here and make sure you take a close look at the equation. Now right now this equation is in a different form than what we want, but if we actually go into the equation, if we double click on it, it should be showing it as function notation, which you can see that it is right here. So we apply that, say OK, and we've got our transformed function, but that doesn't have any restrictions on it. So what would that look like if we restricted it? Then I'm just going to put it right over top of the previous one. The way you do it is you type in fun, and that brings up the template for function. Hit enter, and now for the function itself, I'm going to repeat what I put in there before, which was, let's see if I can remember it, negative 0.5 times f of bracket x minus 10, close bracket, plus a vertical transformation of 12. The difference is now I have to also include the starting x value and the ending x value. So I'm going to do this one from 6, and I hit tab again, and I'm going to do this from 6 to 12.5, something like that. I'm trying to match this to my graph, and I hit enter. Now, you might be able to see what happened there. I can see it on my screen, but maybe in the video it doesn't show up. So what I'm actually going to do is I'm going to go into this and look at the properties of the new one I just added, so you can see the difference. And I'm going to change the color to red, and I'm going to change the style to something a little bit thicker. And now hopefully you can see that in the video. The thin black line in behind is the transformed function, just unrestricted. So the domain and range are negative infinity to positive infinity. The red bolded line is my restricted function. So it's still the same transformed function, except for it starts at 6 and it ends at 12.5. And you can see those if I put those vertical lines in there. If I put in x equals 6 and I put in x equals 12.5 as vertical lines, there, you can see my red is between those two lines. Okay, so that's a brief introduction to using GeoGebra to verify both your transformed function and domain and range. Please keep in mind that you will have to restrict the range yourself. The domain plus the equation are what define the range, and so that's why I don't actually enter the range when I'm doing this in GeoGebra. Something to keep in mind also is you can actually check those two endpoints the same way. You want to find out how good your equation is. Well, that's one way you could do it. You could substitute in the lowest value of your domain into your equation and see whether or not you actually get that value for your range. You can substitute in your highest value. Now, in this case, the domain and range would be between this value, 4, but the maximum would actually be 12. So that's not always going to work for you. But you do get the idea of how you can put various values into your transformed equation and see that they match your graph. Okay, I hope that was helpful, and good luck with your summative.